clearly a lot can be reverse engineered about our thought process and the meaning of words and and all sorts of levels of structure of language and such. At the same time, let's be realistic. It's not observing every neuron in our brain. There's going to be a ceiling, and it's I think that the narrative that says it's going to sort of break through and there is no limit, or that is to say, the Skynet's the limit, right? That narrative buys into this Platonic ideal of intelligence, the sense that, well, once it gets kind of smart enough, it can smartify itself, right? And I think that that's essentially
like a recursive loop of AIs designing better AIs. The kind of the hard takeoff scenario is what you're describing. Yeah,
yeah, and that's I believe that's the modern day version of a ghost story. It's the novel that Mary Shelley would have written if she knew about algorithms.
I love
so
that.
That's a cold, right? But I mean, look, we don't have to create a religion out of this. We can be super excited by what it actually can do and the fact that it will, to some degree, get a lot better. I don't think we're creating artificial humans.
Hey everyone, welcome back to the Ignite podcast. Today we're delighted to have Eric Siegel on the program. Extensive background in AI machine learning, one of my favorite subjects, obviously. For anyone who's been listening to this, you already know that. PhD, he's the founder of Machine Learning Week, which is really cool. He's been a university professor, has a bunch of books. Thanks for coming on.
My pleasure, Brian. Thanks for having me.
Well, I'd love to hear from the horse's mouth and get an intro about you for the audience.
I've been in the machine learning field for more than 30 years. I was a professor at Columbia University, where I got my PhD before that. I've been an independent consultant for 20 years, and now I'm the co-founder and CEO of Gooder AI. As a consultant, I founded the long-running Machine Learning Week conference series, formerly Predictive Analytics World. There's been a lot of change to jargon, a lot of misunderstanding about and perhaps exaggerated expectations of the field, but there's also some really amazing stuff as far as what it's capable of and the value that it does deliver, and even more so the potential that it has. So that's sort of my overview.
And a lot of people think that potential is limitless, right? I mean, you listen to some of the interviews by some of these gurus out there. I was just listening to the Moonshot podcast, and he had the founder of Stability on there, who I think recently left. But I mean, the kind of stuff that some of these gurus are saying about the next 5 years is absolutely crazy.
Yeah. So I'm gonna splash some cold water on some of that hype, which can be refreshing, right? Cold water is refreshing. So as a nerd, I think machine learning is the next best thing since sliced bread, and have always felt that way. Large language models and other types of generative AI, even more so. Just because they're amazing doesn't necessarily mean they're valuable. In a nutshell, I've seen AI hype in many forms over the decades. The form that it's taking now, my sense is that it over promises autonomy, that it's still a tool. Humans run the world. Technology, as amazing as it is, needs to be used in a way that follows a credible, concrete value proposition. And I think the narrative, I mean, this is a straw man, or you can turn me in, you can turn what I'm saying into a straw man, because I'm talking in very general terms. But in general, there's a narrative that inflates expectations with a story about autonomy that I think is unrealistic, including the whole AGI thing, which is sort of undercurrent a lot of the technology. At the same time, it's unprecedented what it can do. It's definitely adding efficiencies. Can help to put a frame on it by comparing generative to predictive use cases of machine learning, if you want to go there. I don't know. How would you suggest we frame that discussion as sort of identifying specifically what do we think it's actually capable of, and what's ghost story?
Yeah, no, it's really interesting. I mean, you've been around it a lot longer than I have. I got into AI probably 2011, 2012, kind of at the nascent side of deep learning, right? And worked at some really exciting AI startups, some unicorns and stuff like that. So I don't know. I've seen a lot of progress in the last 10 years, but yeah, I think you're right. I think it gets overhyped, and then just like the Gartner hype cycle, it just like a peak of like hype, which we're kind of like maybe on the other side of with large language models, and this trough of disillusionment that occurs after, and then the plateau of productivity. Right, that's the framework.
Yeah, the problem with the Gartner hype cycle normalizes it as if this is what has to happen for any
Mm.
potentially valuable or exciting technology. I'd like to be a little bit more optimistic than that and think, hey, maybe we can stay somewhat reasonable. In the case of generative, my feeling is that the valuations and the amount of resources thrown at it are at least an order of magnitude. So this is cognitive dissonance for me, right? As a nerd, someone who started with machine learning in 1991 or 92, and at the same time focused largely on linguistic models, right? So trying to work with natural language. I never thought I'd see what we see now. I think it's absolutely dumbfounding.
Yeah.
And clearly uncanny, seemingly human-like and all that, with the sense that it can reason. And in certain way, in some definition of the word, it sort of can.
Yeah.
But I think what's hidden and what's less obvious is the remaining distance between what it can do and what people can do, and the extent to which that distance will remain. I mean, how much can you reverse engineer the human mind based on learning only from limited observations of human behavior? The written and spoken word, like the input for a large language model's training, so that's observe human behavior. I wrote these paragraphs and then I wrote this word and then I wrote this word, right? And that's literally, those are the learning cases from which it's on which it's training the model. Clearly, a lot can be reverse engineered about our thought process and the meaning of words and all sorts of levels of structure of language and such.
Yeah.
At the same time, let's be realistic. It's not observing every neuron in our brain. There's going to be a ceiling. And I think that the narrative that says it's going to sort of break through and there is no limit, or that is to say, the Skynet's the limit, right? That narrative buys into this Platonic ideal intelligence, the sense that, well, once it gets kind of smart enough, it can smartify itself, right? And
Yeah.
I think that that's
like
essentially
a recursive loop of AIs designing
yeah.
better AIs. The kind of the hard takeoff scenario
Yeah.
is what you're describing. Yeah.
Yeah, and that's I believe that's the modern day version of a ghost story. It's the novel that Mary Shelley would have written if she knew about algorithms.
I love
So
that.
that's a cold, right? But I mean, look, you don't have to create a religion out of this. We can be super excited by what it actually can do and the fact that it will, to some degree, get a lot better. I don't think we're creating artificial humans.
I'm seeing some really crazy demos though. I just got off of one with a European founder. Really cool team building some really state of the art stuff. And the demo was insane. Like you're talking, and he'll be on the podcast eventually because we're probably going to invest. But I won't name names or anything. I won't give anything away. But it was like one of the coolest demos I've seen probably in the last like 6 to 12 months.
Mm-hmm.
And basically, it's a natural language interface, just like ChatGPT, but it has this self-building agentic workflow. So you can describe it tasks, and it goes and just executes those tasks for you. And if it gets stuck, it just comes back to you and says, "Hey, I'm stuck. I need your login to LinkedIn or whatever." Or, "Hey, I got stuck on this," and it can just do things automatically. And they're calling them AI workers, and it's insane. And so, I tend to be on the more bullish end of the spectrum of like, I think the future's here. It just hasn't been distributed yet. It takes 5 to 10 years for this stuff to kind of weave its way into kind of society and business.
So the problem is, so I just sort of philosophically disagree, obviously, because I don't have details, right? When I hear a story like that, I just want to get my hands on it and audit it so we can sort of put it in its place. Yeah. To what degree is it really going to be autonomous? So I would say I'm highly skeptical about that exact kind of narrative.
It's not AGI for sure, but it's like,
but
task as a service. Like I need to do this repetitive task. So instead of paying a contractor to do it, I could just have this AI do these workflows, and just talk to it like I would a contractor.
Or whatever the demo's showing, it was like a use case that it fits well with. The question is just to what degree does it generalize so you don't have to put in the effort in programming yourself or whatever the template you're trying to get to message all your LinkedIn contacts or whatever it is in this case. The problem is if you're going to sort of very quickly, these debates about the hype of AI turn into, they really bifurcate in a way that you could really draw an analogy to the political bifurcation, right? You just end up on completely opposite sides of this dire argument. Both sides are very invested and feel territorial about it. I don't think it has to be that way. I think that it's so easy to get there, right? So if we really wanted to have, put our monies where our mouth is, we could have a bet, but you'd have to make a bet about something very, very well defined. And then once it's well defined, it becomes.
We should make a bet on this podcast, because it sounds like I'm a techno optimist and you're more of a techno.
Except what I was going to say is it's really hard to define. I mean, they do exist, like Gary Marcus famously, I guess, bet Elon Musk, like it's not going to be able to do X, Y, Z. So if we could come up with X, Y, Z, the thing is, and if we did, it would sort of be only tangentially related to the sort of sense of a broader philosophical question. But it also would be a lot less contentious, because then we'd just be talking, okay, look, is it going to be able to create, an entrepreneurial endeavor and develop its own product and market it and be worth $1 billion? Are we going to have a machine that can do that autonomously within 5 years? Well, that would be pretty well defined. I would say definitely not, and I would bet a lot of money that we're not going to.
I wouldn't bet that $1 billion company run by an autonomous AI agent.
So maybe I'm making a straw man, right? But I have heard.
I think it was Sam Altman and his friends made that kind of bet collectively.
Right. So there's people, maybe that's going too far, but I think you could go a lot less far and I'd still bet against it.
Yeah, I agree. I think you what's the probable future is there's this kind of centaur human relationship, right? Where you still need the human in the loop to guide it and be creative and imaginative. And but I am seeing this contracting. Yeah.
Here's one I think is pretty good. I've only tried this out on a couple of people. I think that you'll have the benefit of like a chatbot that, a large language model that operates in English, and to use that within the context of a chatbot is that you can use any turns of phrase. It can kind of be informal the way we are with each other as humans. And that's really valuable. Let's say I'm a field work and I'm fixing washing machines. But, I'm an expert, but I don't know everything about every model of washing machines. And then I'm on the field. I've got an issue, a situation. I can't figure out what's best to do with this broken equipment. And then I can just start chatting with the thing, right? I believe that within that, for that kind of problem where the domain is constrained really well, where you don't have not about any topic, it's just about the history of wine or how to fix this category of washing machines or something like that, right? I think that's totally within several years. It's feasible. It'll make errors or that are unacceptable very rarely enough. I think that's possible.
Yeah.
Whereas take another step and be like airline customer service. I'm going to call the airline. I'm going to be like, look, I have this flight, but you guys changed it. That's not fair because of this. You need to override this regulation. I should have economy plus seat. And the airline reservation system is so arcane and convoluted, and the sort of area of what kind of manager can override what kind of regulations. I think it's going to be a really, really, really long time before we have a language model that can autonomously, or any system that can, without a human, autonomously handle those types of airline calls. So I'll say 25 years.
Wow, so 25 years?
Yeah.
Wow.
Yeah.
That's crazy.
So that's my vantage on it. Yeah.
Because haven't they already started implementing these in call centers and automating like 80, 90% of the customer service requests?
They're bad, right? I mean, show me the data. You're hearing a lot of noise and stuff and a lot of speculation and a lot of hype. So that would be one way to put it. Now, in our startup, we present a way to look at a predictive model, which is sort of the original. It's the older school AI, but it's older, but it's not old school. Still, most of its value is untapped. So this needs a business console so that you can look at a predictive project and be like, should I deploy this model? How much business value in terms of profit and savings is it going to potentially deliver? This is the main technical piece missing for driving these predictive projects. It needs to be understandable and accessible to business users, stakeholders who are in charge of the operations meant to be improved by a model. Only in that arena, we're in one of those more constrained domains. So indeed, even though I'm out there, somebody might label me a skeptic because I'm like, look, the hype is really catching on like wildfire and it's to all of our detriment. At the same time, I'm like, look, with our product within this constrained domain, it's serving up these two-dimensional charts and levers and that are supposed to make it accessible for a non-data scientist to look at how much can I improve operations, fraud detection, targeting, marketing, retaining customers, liability modeling, logistics, all these typical predictive use cases. We need the business stakeholder to look at it. So they want to be able to converse in English, right?
Yeah.
They want, without worrying that they're spending the time of an expert who's getting impatient with them, they want to go back and forth and be like, well, what does this chart mean? What would it mean if I move this line or change this lever? And why would I want to? Just those intuitive questions and the back and forth. It's such a constrained domain. And those charts are so well defined and clear that from our initial experimenting, this is exactly the kind of constrained domain where I do think large language models are very close, if not already ready, to handle it very well, get the right answer as often as you would hope, get the wrong answer as sufficiently infrequently. So, deployment of generative, I'm very bullish on.
Yeah, that makes sense. So tell us about your transition. I mean, you've been in ML for 30 years. Is this your first startup, and why do a startup now? Of all the things you could be doing, you have such an incredible background. You've written books, you've been a professor.
It took me 30 years to have the idea. So not the basic idea, but the particular implement, like the direction of it. So I can explain that. I co-founded 2 startups at the turn of the century. And then for 20 years, I was an independent consultant running the conference and doing consulting engagements, wrote the books. All along, it's become clear to me that within predictive has some benefits over generative, right? If you had to compare. Now, you don't have to compare. It's not a zero-sum game. The 2 areas, should compete no more than a water park and a ski resort. But generative sucking all the oxygen out of the room. So it's hard not to compare. There's a couple reasons to compare. Given that there is a degree to which it is a zero-sum game, I think it's important to put out there what I believe, which is that depends on the organization, but in general, you should be spending as much time and energy looking into predictive use cases as generative, even though it's not as cool, it's not nearly as sort of amazing. But predictive is what you turn to improve your existing largest scale operations, right? So prediction is the holy grail for improving all the large scale operations as far as who to contact, investigate, incarcerate, set up on a date, or medicate, which train wheel to investigate, and which satellite that might run out of battery, and which component of a hydropower plant might break down, and healthcare. I mean, it's just, it runs the gamut. And in that case, the predictions that machine learning delivers are operating on that level of granularity per human, per customer, per unit, per car, per organizational unit on that level, rather than per word, essentially.
But this is a really developed area. I mean, I was working on predictive AI technologies over a decade ago.
Right, but it's not developed enough because they're not getting deployed. Most new machine learning projects fail to deploy. There's been more and more research coming out. So go back 2 years before generative, you're seeing hype. When people say AI, they mostly mean these predictive use cases of machine learning. And yet, it's still a different kind of hype. One is that there's always been this narrative of AGI and autonomy, because it's the coolest rocket science, and it is. I mean, the idea of learning from data to predict is really, really, really cool, and that's why most data scientists like myself got into it in the first place. That doesn't mean it's intrinsically valuable. It's only valuable if you act on it. If you deploy it, operationalize it, if you change operations don't get better and improve and deliver value in that way unless they change. So the predictions that are output have to directly change. That operationalization fails, okay? It may succeed about 20% of the time, which 20% of a lot of projects is a lot, but it's overall a dismal track record. One research project that I was not involved in, with our results as well, came from IBM. When they looked at the business process, they pulled the business side rather than us surveying the data scientists. Same story. The average returns are essentially zero. They're lower than the cost of capital across these projects. The world's become very adept at sweeping these failures under the rug. But the frank, cold news is that these projects, especially outside of big tech, where you've got a very different culture and context, but in general at large, it's a great idea. They make the model with the intention to deploy, and of those models intended to be deployed, the majority don't deploy.
I think that's the process of creating, though. I mean, I built a lot of tools and projects, and like we'd have a model and like we didn't deploy it because it wasn't good enough, or you know what, this other model was going to work better. And this happens in product management more generally. When you're building products, you'll have a hypothesis and it turns out not to be correct, right? And I've built a lot of stuff that nobody used, right? Like, this is going to be the coolest product that we've ever built. And, we ship it and like nobody uses it. And we're like, oh crap, what did we get wrong here? And, obviously predictive AI is a little different. ML is a little different, but I remember having ensemble, models of dozens of models, like, and we're putting them all against each other and trying to improve the F1 score for, classifying intents, So I think what you're describing is just the creative process of creating.
I'll push back on that, because from everything I've heard and from the results of our surveys, people are very rarely saying a model didn't deploy because it's not good enough technically. What happens is it's an endless loop of frustration of data scientists. They give them a good model and they don't get it. And part of it is because of what you just mentioned, the F1 score. F1, area under the curve, precision recall, these technical metrics mean nothing to the business side. And that's exactly the issue that we're addressing with Good or AI. So what happens is you pass the ball and they don't catch it. It is good enough. It has all the potential in the world. And it's not just a matter of, oh, well, the model needs to be a little bit better. Let's circle back. No, the whole project dies. This is a frequently heard story, and is the one that pans out in the survey results and industry research we've been seeing. So that's the theme of my newer book, the AI Playbook, is that we need a very specialized business size practice playbook paradigm. And that's what I present in the book, to ensure the end-to-end participation of the business side. People collaborate. If business stakeholders don't get their hands dirty, their feet will get wet. They won't deploy the model. They need to be involved, understand the gist of it. And you need to plan in reverse so that the whole project is reframed and planned around that actual deployment, rather than the sense of, hey, we're doing awesome number crunching and we'll think about how it gets integrated later.
Yeah, so let's break down. You have the 6-step BizML framework in your book. Let's break down how that framework kind of prevents this from happening. Like, the data scientist builds a predictive model. I can predict, if we do X, Y will happen. And then where that breakdown happens. Yeah.
So the steps start with pre-production before you're even doing the modeling. That's sort of the whole point. So taking a step back, what business stakeholders need to understand about these projects is what's predicted and what's done about it, and how well it's predicted. So that sort of trio where they need to get involved in some nitty-gritty detail. It's not the rocket science. It's about how to steer the rocket. That's the reframing, right? Instead of being more excited about the rocket science than the actual launch of the rocket, let's plan this whole project around what it's going to take to actually launch it, to change operations by integrating the model, launch the model in that respect. But, what's predicted and what's done about it, that defines the use case of predicted. That defines the use case, the value proposition of any given predictive project. So who's going to buy, then target them, which transaction is likely to be fraudulent, then block or audit it, who's going to be a good debtor, then approve their application for a loan, which train wheel is going to break down, et cetera. So that pairing, which healthcare patient is going to degrade in health, that pairing of what's predicted and what's done about it, there's so many of those pairs. And I see new ones in machine learning projects across my desk, at least a couple times a month, that I never thought of before, and that's for 30 years. So the wide applicability that Harvard Business Review calls it the most general purpose technology of the century, or the most important general purpose technology of the century, right? So that applicability is great, but you got to start with that as the very bare bones. But you're not done. That's literally only the first step. So what's predicted and what's done about it? What's predicted has to be defined very, very specifically, but that's involves business pragmatics. And it defines, for data scientists out there, that defines the dependent variable, which is then manifested only by way of the data prep, more so than the modeling process itself. And then the metrics is where things seem to fall short most often, which is that the data scientist gets very excited because you see a technical metric like F-score, precision recall, even accuracy is only a technical metric. They tell you the pure predictive performance in a vacuum with no regard to the business context or the potential usage, the deployment plan, how it's going to make a difference.
Right.
If you involve that context, then you can actually calculate a business metric like the potential profit or savings that you're going to get. That's the only thing that matters to the business, right, and to the stakeholder. That's generally missing. Step 3 of the 6 steps is to define those, get everyone on the same page, and set the standards for both the technical and business metrics. And then the other 3 steps, just the technical steps that all data scientists know that have always been the same since we were starting to use predictive models in the 60s for targeting, marketing, and credit scoring, which is prepare the data, train the model, and then deploy it. So most business stakeholders out there don't realize that to get these predictive projects in place and improve large-scale operations, you do need to follow a very specialized kind of process, practice, or playbook, let alone know the name for any of them. So the buzzword I coined and present with this book is BizML, B-I-Z-M-L, business practice for running machine learning projects, with the hope that that snazzy branding, is going to help get the word out there, have something to hang your hat out on it, and help bridge that gap so that the business stakeholders understand, okay, I need to understand some details about what's predicted, how well, and what's done about it. I need to get involved with that knowledge from end to end across the 6 steps so that I can participate and ensure that this thing actually gets greenlit and successfully operationalized.
Yeah, I love that. So I think back to a lot of the predictive projects I worked on. I mean, I worked at Rocket Fuel, AI, ad tech unicorn. We predicted, hey, if we showed this ad, will this person buy a pizza? Right? Direct response advertising. That's pretty clear, right? Because you're paying a certain cost per impression. And then if you can, predict that at, I don't know, I'm just throwing a number out there, 2x the precision or whatever, you basically half your advertising cost. So that's a very clear cut example to understand. But there's these other use cases that you're describing that they're a little bit more amorphous, right? Like, okay, what is the value of predictive maintenance? Okay, well, if the machine goes down, and we didn't predict it would go down or it needed maintenance, the average downtime is XYZ, and that will cost us, and millions of dollars per hour or whatever it is. And so exactly. So the data scientist basically needs to, work with your business analyst and basically say, hey, I just made this 20% more effective. Let's try to translate that into business value so we can communicate that to the execs, right?
Right. So what happens now is people kind of wave their hands. What's the point? We'll find out how much value later in postmortem. They'll do a bespoke solution using Excel or something like that, which is sort of the definition of where there's a startup opportunity. So the way you just put it about it being amorphous, you're hitting the nail on the head, because the thing is it's amorphous in the sense that there's a bunch of uncertainty and unknowns once you go to the full business context, right? Yeah. If you want to
further you get from the math, the more it's kind of like subjective, right?
Right. It becomes less abstract and less contained in this world of abstraction, which I think is why I started loving computer programming at the age of 10. It was like, I can control this. I know exactly what it's going to do.
I put this in and I get this thing out consistently. Yeah.
So now I'm getting back to the real world. You have to open this can of worms. But here's the deal. If we don't open this can of worms, we're going to continue to have this failure rate of these projects because there's this disconnect, right? The data scientist says, my reliability model that I built on your request is got an area under the receiver operating characteristic curve of 0.83. Isn't that awesome? And then, the stakeholders like, well, how much is it going to cut costs by, preempting breakdowns and by triaging inspections, or, however the basic value proposition works, which is pretty straightforward. The data scientist is generally not prepared to answer the question. It's not in their training, and there's no software to do it. So that's why it requires a whole product. Because when you open that can of worms and you're dealing with that amorphous, or let's call it uncertainty nature, you need to parameterize your revenue model or your cost-saving model or whatever, which the model itself is not that complex, right? This is just arithmetic, but it's very particular arithmetic and rarely done arithmetic. Yeah. And it includes factors that are subject to change or uncertainty. So what you need is to visualize how big a difference they make. Oh, this doesn't make that big a difference in terms of how we're going to deploy this. Oh, this one does. Let's go back on the field and do a few tests to decrease that uncertainty range. But it requires a very specialized graphical user interface that you can try out. So that's why we need this new category of machine learning software. It's not the model training. It's not the rocket science. It's stress testing the rocket in its intended usage.
Yeah. So it sounds like Gooder is trying to do that as a platform. This new startup it's trying to bridge that gap between, hey, from a data science perspective, this is way more accurate or whatever. And from a business perspective, this is how you visualize that and bring that together.
Yeah, exactly. And you can think of it as a console, right? The control panel for the business user, because all of these aspects, none of it's rocket science. It's like, oh, okay, how am I going to use this model? Am I going to use it to block the top 1% most likely fraudulent transactions, or the top 1.5%? That's a really big difference when you've got millions of transactions. You need to be able to slide these things, try it out, and see how competing metrics pan out and all that kind of stuff.
And you know what's more infuriating as a business person, right? I ran AI product management where we at another startup, we built a sales chatbot, and one of the executive questions that would come in the room in these like reviews is, great, like how much more accurate will the model get if we spend another month on it? And you go back to the data science team, and they actually don't know. They don't know. They're like, we'll try some stuff, and we're at 80% accuracy right now. We think we can get it to 90, and a couple more sprints. And that's for a business person. That's like, what do you mean you don't know? I thought you guys were data scientists.
Any data project is got a sort of R&D element to it. So there's always that. But I'll just reinforce in that conversation, swap out accuracy for potential value, right? Because accuracy and other technical metrics do little to nothing about the potential revenue savings or cost savings or profit that you'll get from deploying it.
Right. Well, I think that's the calculation they're trying to get, is they're saying, okay, 10% more accurate. We had a human in the loop when we didn't have a certain score on the classification, and so we'd send it to a team, and that team has real costs, and the data science team has real costs. So like they're trying to, I think business people are trying to make that calculation in their head, is like, okay, if we could defray 10% of those going to that human in the loop team, then we can save X dollars. And what is the input to the output, right?
Yeah, I mean, so there, that's you don't know until you try. But I'll just say one thing in a nutshell: it's usually getting more or better data is the thing that makes a bigger difference than moving to a more sophisticated modeling method.
Right. Yeah. I mean, let's tug on that string a little bit, because that's something you hear a lot in machine learning circles. It's all about the quality of your data, like the annotations, and this is something that OpenAI did with their generative models, right? Is they just had really good annotations and humans in the loop. Can you tell us more about that?
So whatever you're trying to predict, we don't have a magic crystal ball, right? What we generally have is predicting a lot better than guessing. Still maybe predicting poorly compared to a crystal ball, but it turns out to be really, really valuable. But it depends on the domain, right? So if you're trying to predict customer behavior, which is the case for many of these, who's going to click, buy, lie, or die, you're not going to be able to predict like a magic crystal ball. If you're trying to predict, hey, is there a traffic light in this image? Does this radiology image connote a certain medical diagnosis? It turns out that we can do as well or better than humans, which is sort of close to what you'd imagine a crystal ball, right? It gets most positive cases correct and it gets most negative cases correct. So it depends on the domain. In the case of large language models, well, look, if I've written this paragraph and a half and I'm trying to predict what should the next word be, there's not only one correct answer, right? So basis for evaluating how well it does becomes something else, right?
Yeah.
And partly subjective. If there's anyone listening out there who's not tried ChatGPT or something like that, then what are you waiting for? It's crazy. It's amazing.
It's fun. It's so funny you mentioned that, because I heard a statistic, something like 80-90% of the adult US population has not tried ChatGPT. I had a friend who's like, I don't want to pay for it. I'm like, there's a free version. Just go try it out. And now he's been sending me all kinds of funny things from it. And
I mean, if I didn't have kids, it's literally all I would do. I might watch a movie every once in a while.
Yeah.
So how do you measure how good it is? Well, it depends on exactly what you're trying to use it for. So right now, part of the hype is fueled because it does really well on sort of standardized tests and tests that are meant to evaluate human intelligence. There's a big difference between measuring the aptitude of a human and a machine, right? Because if I say, hey, look, this human did well in the LSATs, we know that is a nice surrogate for general capability or aptitude of that human. You can't say the same thing about a machine. You can't make that presumption. You can't leap from that to some general sense. What we have to do is, and we are doing it a little bit.
Really good on a narrow subset of ability.
Well, and if you want to know how valuable it is for some particular task, you need to evaluate it on that very task, which is done a little bit. Still early. Starting to see that, writing marketing materials more effectively, coding, obviously. So you're helping a person, a human customer agent who does online chat customer service, and then they use the language model to help them. So these things create improvements of efficiencies by like 30 to 60%. That's the kind of thing we hear about. We hear about bigger numbers, but we don't really see the data. We hear promise of bigger numbers, but they start to become less than credible. But those efficiencies are very meaningful and amazing, unprecedented. So where do we start with this? We were talking about what it takes and what kind of algorithm you need to get the thing better, right? So if you're trying to predict something that's unpredictable in the sense that you can predict better than guessing, but we're never going to have a magic crystal ball, no matter how sophisticated and how much data, such as the outcome and behavior of humans. Those types of use cases, there's sort of an intrinsic ceiling to how well it could predict. That's why it's not really necessary to get that sophisticated. You don't need a neural network with millions of weights, because there's very quickly diminishing returns on how well it can do. But when you're trying to get a thing to say what would be the viable or some of the most viable next words to write, the only way it's going to do that is having a very sophisticated processing of what's been written so far before this word, right, and in some level capturing the meaning of it, right? So that's why neural networks, the thing that's so dumbfounding with deep learning was that neural networks actually did scale, because for a couple decades there, right, all you heard was they're cool, but they don't scale. They reach a plateau, right? And then all of a sudden, with the right computation, enough data, some tricks, eventually people broke through that barrier, and all of a sudden that was the deep learning revolution.
Yeah, the big unlock was basically two things, and maybe you can correct me or build on it. One is, compute scale, right? We had compute scale GPUs and stuff like that, but also backpropagation, right? That was kind of the big unlock of deep learning.
Not exactly. Backprop has always been virtually synonymous with neural networks. Since their inception in the mid 80s, it was always backpropagation, with the promise that you could make the network more and more sophisticated, bigger, right? Literally deeper with more layers. And then the learning process it's sort of analogous to, you make a mistake and someone slaps the back of your hand, and then that pain goes back, and every component that made an error gets proportionally penalized accordingly, or that is to say adjusted as a weight. And that's still how it works. It's just that there are a lot of details about how to implement it. So for example, so each neuron, as it were, and the biological terminology, by the way, I would caution listeners not to read too much into that.
It's kind of like a metaphor. Yeah.
Yeah. It's basically you take linear regression and then you scale it, but you can't just if each one is basically a weighted sum. Almost that simple. It's a weighted sum with some kind of nonlinear transformation. Nonlinear transformation sounds complicated, but all it means is that you change it not by multiplying a constant, but with something that depends on the value. So if you drew a graph of it, it wouldn't just be a line. That's what makes it nonlinear. So in any case, you need that little twist, because if they were just weighted sums with nothing else, and then you put a network of them together, all you'd be doing is making a weighted sum of weighted sums, which turns out to just be another weighted sum. So if you wanted to do something more complex, you had to put some of that little transformation
kind of the soft maxes and stuff like that, where you have to make a decision whether, hey, is this neuron on or not?
Right. So for a couple decades, it was basically the S curve, which was sort of like a fuzzy boundary of going to yes or no, 0 to 1. Now it's turned out to be more like a hockey stick, which is also not a straight line, obviously.
Yeah.
Things that everyone just thought were the best practice for decades, all of a sudden, wait, that simple little hockey stick line works better? That's crazy. And it's actually working now, and it's scaling. So the whole thing has been amazing. And then the extension of that was doing it for next word prediction, or next token to be more exact.
And by the way, for anybody listening who wants to get a good visualization of these concepts, I would recommend 3 Blue 1 Brown on YouTube. I watch all his videos, even though I know machine learning pretty well. His visualizations of this stuff is just second to none. There's just nothing better that I've ever found on the internet.
of like backprop and stuff like that.
Just all these concepts, yeah, all those
Yeah.
all these mathematical
So
concepts, and yeah.
so I taught the machine learning course at Columbia for the first time the fall of 1997.
Wow.
And what happened just in time was one of the first totally complete, nice textbooks. Textbook might sound like a boring word to you, but at the time it was like nobody had taken all of the different competing methods, neural networks, decision trees, log linear, and a whole naive Bayes. Nobody had taken them all and sort of put them nice and uniformly in a relatively accessible way compared to these technical papers. Textbooks may be dry, but they're a lot better than technical papers. But this came just in time, and it's by Tom Mitchell. I think is now retired. He was professor at Carnegie Mellon. He has great visuals in that book. It's called, the name of the textbook is called Machine Learning. Go figure. And it has great ones. And it was already doing, it had a demo already for the self-driving car driving around on the highway around Carnegie Mellon campus with a very low resolution camera, 32 by 32 or something like that.
Wow.
A neural network on a really old looking laptop, and a person's hand like literally right here on the steering wheel, only on the highway, only, daytime.
Oh, amazing.
But he shows the intermediate layer weights and how it has emergently kind of realized, oh, I should be sensitive to something that kind of looks like the road ahead of me is veering off to the left. And that's going to mean I should steer the car to the left. Wow. Right, which is a great visual because nobody programmed those weights explicitly, right? This emerged because of the backprop learning process. So yeah, so I'll have to check out what you just said. I don't think I've seen
Three
it.
blue, one brown. Yeah, very, very cool.
Yeah.
My favorite YouTube videos. I just like to nerd out on the couch late at night after everyone's gone to sleep, and I'll just watch these random YouTube videos like that. It's just really good. So tell us about kind of the founding of Machine Learning Week. What was the origin story there?
So after I left academia, after the two startups at the turn of the century, then I'm like, I'm moving to the West Coast and I'm going to be an independent consultant, but I wanted to keep teaching. So I started doing these 2-day training programs, always in person. Now it's all in an online course. You can go to machinelearning.courses. It's just sort of, I started doing it alongside a conference that at the time was called eMetrics, and the producers were like, hey, wait, this topic deserves its own conference. So that was 2009. So we were Predictive Analytics World for a while, and then we had a sister conference called Deep Learning World. Now we're Machine Learning Week. And that kind of goes along with the terminology. Like when I started as an independent consultant in 2003, I wanted to call it machine learning. I would go to people and I'd say, hey, do you want to do machine learning? I'm your consultant. What is that? Yeah. And then they'd be like, what the hell are you talking? Just the eyes were glazed over. And at the time, everyone was calling it data mining, which is a horrible buzzword.
Yeah, I remember that. Yeah.
But the term that just hit the scene was predictive analytics. I'm like, oh, that's the word. So that ended up being the title of my first book and of the conference.
Yeah, that's awesome. Well, let's switch to a rapid fire. What's the most exciting application of machine learning you've seen recently?
No, I chose for the head of my book that came out early this year, UPS case study, since it's such an amazing thing. So look, there's nerdy excitement, and I'm as excited as the next nerd about generative. But at the same time, in my career, I'm really married not so much to the coolness of the technology anymore, but to its actual deployed value. And if you think about UPS, which is more than 100 years old, how are they going to change their ways? It's one thing to have a great idea. It's the other thing to actually get the organization to change. So it's just such an amazing story. They predict the packages that are going to need to be delivered tomorrow in order to more optimally deliver them. So at each of the 1,000 shipping centers in the U.S., they have to start planning and packing the trucks in the late afternoon or evening overnight so that they can get them ready for on-time departures the next morning. They have to do that with incomplete information because there's other packages that may or may not be coming in or that they don't even know about. It's a complex system. So what they do is they augment the known packages that they have in hand with predicted or presumed packages of where there's going to need to be deliveries by what time tomorrow. And by working with those kind of tentatively presumed deliveries to make with a more complete picture of all the deliveries, they can do a much better job creating the overall optimal packing of, well, this truck gets this region that includes these packages, and this truck gets this one, et cetera. They might have 50 trucks. And by doing that in combination with also prescribing driving directions, UPS to this day now enjoys a savings of 185 million miles of driving a year, $350 million,
Wow.
185,000 metric tons of emissions. So this was not clockwork, right? You know, they had the idea, they did a bunch of proof of concepts, but they had to work real hard against organizational inertia, understandably, right? I mean, there's intrinsically going to be a resistance to change and adversity against risk, but no risk, no reward. So it was sort of a battle going both up and down. So the hero of the story, Jack Levis, who was a director, had to go up to the executives and convince them, and then ultimately in deployment, convince the loading dock workers to follow the prescribed instructions, you know, rather than overriding it because they think, oh, well, these packages definitely belong together on the same truck, based on their knowledge of the neighborhoods and such. So, yeah, it's an amazing story. It sort of bookends my book with the early and late chapter in the book about different chapters of that story. It's a real kind of melodrama of trials and tribulations.
I love that. So speaking of books, if you could recommend a book on AI besides your own, what would it be?
And I have trouble recommending just one. So I mentioned machine learning.
3,
I'll always love that original textbook. There's been a lot of them since then, but you really want to be nerding out on just the core algorithms. But anyway, my answer to your question would be Mining Your Own Business, which is by Gerhard Pilcher and Jeff Deal. They work together at Elder Research, and this is one of the, well, it's a boutique consulting firm, but I think they've had at least...
So it's mining instead of minding. It's mining your own business.
Yeah, it's a joke. Mining your own business. Yeah,
a little pun there. Yeah.
And I had that in a slide before their book. What's mined is yours. Yeah, this is an old slide. Back when I used to be a nerd. Now I'm cool. But so this book was one of the originals that actually broaches the business side. Very much the missing thing. What I've addressed with my books. It really laid the groundwork for that. And they work at Elder Research, which is I guess you call it a boutique consulting firm. They've got 200, but they're focused on analytics projects specifically, a very wide range across sectors. That's a very formative book. And I'm going to cheat, and I'm going to give you a completely different kind of book. There's a book, I've read all the books. I've read a lot of the hype books. And there's a whole bunch of anti-AI hype books. One of them is called L'Artificial Intelligence N'Existe Pas, which I think is hilarious, but it's in French and I haven't read it. But of the ones that I've read, my favorite is Evil Robots, Killer Computers, and Other Myths. That's by Steven Schwartz. It's also a good overview and introduction to the field at the same time. So,
yeah, I love that. So what's one piece of advice you'd give a company just starting with machine learning, if there is such a company anymore?
Well, there is. I mean, there are at least lines of business. I mean, you hear it all the time. There's so many places where they want to do it. You know, talking to a large pharmaceutical that's got its own shipping company for their pharma packages, and then they want to figure out, you know, how to optimize those shipments and how to deal with packages that are in limbo, where the temperature control could start to fail if it stays in limbo. And like, there are tough choices, and you want to do it by the numbers, right? You hear about these types of stories over and over, and they're like, we're working on it, or we're hopefully working on it, or we haven't triggered the project yet. So there's plenty of places where people haven't started yet. But that's the first step, is to focus on a very concrete, specific use case, whether it's a predictive, whatever technology you're using, whether it's generative AI, predictive AI, you know, exactly how operations are going to change or be informed by this, in what way, how are you going to measure that value, in what terms, what metrics, and then follow through, actually get it deployed, actually measure the results.
What is your favorite machine learning algorithm?
Well, I mean, look, I was sentimental because it's been a number of decades, right? So I was in genetic algorithms and genetic programming for a while, but really neural networks won, right? They're the ones that's the algorithm that turned out to do what we were trying to do back then. Genetic algorithms may have a place, may do stuff equally impressive, but the ability for the neural network to take a high-res image and do a superb job classifying whether there's a traffic light or whether there's a medical disease, or these kinds of face recognition, speech recognition, translating, everything that happened with deep learning, which is neural networks. Deep learning basically just means big neural networks, or deep ones. In fact, if you say neural networks, you probably mean deep learning these days in most cases. It won. It's amazing, and it does stuff that we didn't necessarily think was going to be possible.
Yeah. I got a nerdy book, actually. Speaking of algorithms, the Master Algorithm. I don't know if you read that one.
Sure. Yeah, I know
Yeah.
Pedro, and he spoke at our conference.
Yeah. Yeah. Really good book. I read it on a cruise ship. I was on vacation with the family and reading that book by the pool. I remember.
Awesome.
How do you stay current with all this just crazy advancements in AI? It seems like every week there's something new.
Gave myself a promotion, so I'm not hands-on. I mean, I'm hands-on to a certain degree, like with our product. I'm not out there trying to tweak the parameters of propagation for deep learning. I'm not doing that, right? In fact, if I'm spread thin, it's not because I'm trying to keep up with every iota of the actual hands-on number crunching. It's because I'm trying to keep up with the narrative of how people are promulgating hype. I'm very concerned about that, about the overpromising and the disillusionment, which could be much more costly and painful than we need to have. At the same time, how to deliver the concrete, credible value, how to deliver well, and how to explain it in business language, right? That's always evolving as well. So,
Yeah.
sort of, I'm working hard to bridge the gap between tech and biz, and that also involves a lot of sort of knowledge gathering, even if it's more soft skill stuff than hard.
Yeah. What's one thing you miss about teaching?
I mean, it's the students. I mean, that the thing I've always gotten a kick out of is explaining technical concepts to people who care about the value of it, or its relevance, or it's making intuition interesting, right? When I was at Columbia, when I taught machine learning and AI, they were grad courses, but they were for newcomers. And then the other kind of courses I taught mostly were the intro for first year computer science majors, or even the elective, that is to say, computer science for poets. I've always loved kind of like making it
Got a real class,
accessible.
computer science for poets.
Like physics
Oh,
for
okay.
poets, like they need a science election, so they take computer science 1001 or whatever it
Yeah.
is. That's not meant for majors. It's meant for sociology majors or whatever.
Right.
And yeah, just sort of getting that energy of like people who think, oh, it's going to be arcane or dry or boring. And it's the same thing now. So I do it now with keynotes, and mostly I speak to non-technical audiences, and I've been commissioned to keynote 160 times, like 17 times so far
Wow.
this year because of my new book. And that's what I like doing, is like making it accessible. People are bracing themselves. This is going to be boring, hard to understand, but look, it's amazing. I mean, you could do the same thing with a car, right? Let's say you had no idea what internal combustion was. You could make that like a really interesting presentation.
Mm.
There's no reason you shouldn't do the same thing with machine learning.
Yeah. Yeah. Totally makes sense. What's the biggest misconception about machine learning?
That it's highly accurate, I think. I mean,
Yeah.
well, I mean,
Yeah.
unless you want to go over to the whole AI narrative, but sort
Yeah.
of before the more recent blossoming of more intense uh, AI promising, there's always been this sort of like, hey, it can predict whether I'm pregnant, and it can predict, whether I'm going to buy. They know exactly what I'm going to do before I do it. And in fact, a lot of those use the word accuracy, where if you say 90% accuracy, it actually conveys something that's not true, which is that it can tell, who's going to have a heart attack and who's not, and it can, for both positive and negative cases, be correct an overwhelming amount of the time, and it can't. That's a lie. I call it the accuracy fallacy. I have a Scientific American article about it out there, and it also leads the metrics chapter of my book. So yeah, it's sort of like a positive spin on that negative is what I call the prediction effect, which is a little prediction goes a long way. Predicting a bit better than guessing is more than sufficient to drive value by improving operations with those predictions.
This has been an amazing conversation. I'm glad I got a full night's rest. My toilet was leaking in the middle of the night, and I told my wife I'm sleeping in because I got a podcast. So I'm glad she
Oh,
let me
good. You
sleep
got your
in.
priorities straight. So I'm
Yeah,
sorry
shout
about
out
the
to my wife
bathroom.
there.
Sorry about the bathroom situation, but it was
Oh yeah,
worth it. It was
we put a new toilet in, and I heard it running, and I'm like, oh yeah, it
uh,
turns out like the valve's leaking behind it. And I just told my wife, I'm like, I got a podcast today. I'm gonna sleep in. I'm glad I did because this was a really fun
well, at your
conversation.
age, you can roll over and fall back asleep. So enjoy it while it lasts.
I just hit melatonin, just dose myself with melatonin. But how can people get in touch with you about your books, your courses, your events? I mean, your keynotes, your startup, all that stuff.
Yeah, it's all on. I mean, you mostly start with my new book's website. So the book is about BizML, right? business practice for machine learning. bizml.com is the website for the book. There's also a page there about my keynote speaking. There's a page about me, links to the conference, which is Machine Learning Week or mlweek.com. So yeah, it's all on there.
Well, thanks so much for coming on. I really enjoyed the conversation.
Yeah, me too. Thank you so much, Brian.
Thanks, Eric.